Hi, this is an explanation of number 42D on the midterm review packet for M3 Algebra 2. Directions are to sketch two cycles of the graph of y equals negative 2.5 cosine the quantity 4x minus 2 pi plus 1.5. So the format of the equation that you've learned is y equals a cosine b times the quantity x minus h plus k. In this equation, the b value has been distributed through the parentheses, so we need to factor that back out. So think of it as almost dividing by 4, except that we're still writing the 4 in front of another set of parentheses. So that gives me 4 times x minus pi over 2. So here's what we have in our equation. The negative 2.5 is a, the b is 4, the h is pi over 2, and the k is 1.5. So usually what I do first is draw some dashed lines to represent the midline and the amplitude. So in this case, since k equals 1.5, that means the midline runs through y equals 1.5. So I'm going to do a line at approximately y equals 1.5. And then to represent the amplitude, the max and min will be 2.5 units above and below that line. So that means that the top of the graph is going to hit y equals 4, and the bottom of my graph is going to hit y equals negative 1. So the cosine curves are going to wave in between those lines. So now from here, I need to calculate the period. So you should realize that the period does not come directly from the equation. It's related to the b value. So the period equals 2 pi divided by b, which in this case is 2 pi divided by 4, or pi over 2. The h value, coincidentally, is also pi over 2. And this is going to be the first x value of one cycle of the graph. So if I just draw you a sample negative cosine cycle, that looks something like this. What that means is this first key point right here, that's going to happen at x equals pi over 2. And that's because h is pi over 2, not because the period is pi over 2. So when I come up with a scale, usually what you want to do is at least split the period into 4 pieces, or you could do a multiple of 4, 4, 8, 16, 12, something like that. So if I divide the period by 4, I get pi over 8. So that would make me decide that I'm going to make my scale pi over 8. So each of these boxes is going to represent pi over 8 units. So that first box would be pi over 8, so if I count over 2 pi over 8, 3 pi over 8, for example, would be 3 units over. And then 5 pi over 8 would be 5 units over from the x-axis, and so on. So when I graph my points, you could see from my sample cosine cycle, which is with a negative a value, that I have to graph a point at x equals pi over 2 at the minimum. So pi over 2 is 1, 2, 3, 4 pi over 8. So there is a point at the beginning of my cycle. And then pi units goes across 4 spaces. So that will be the end of the cycle. Halfway between those, the graph hits the maximum. Halfway between the first and second points that I drew, it's going to hit the midline. And then halfway between the other 2 points, it also hits the midline. So then that makes one upside down cosine cycle look like this. If I had to write key points for this, I can easily see that my first x value is at pi over 2. And they count up by pi over 8 each time. That next one is at 5 pi over 8. The next one would be 6 pi over 8, which is really 3 pi over 4. And then what were we at? 6 pi over 8, so then 7 pi over 8 would come after that, and then 8 pi over 8 would be pi. So those would be the x-coordinates of those 5 key points that I drew. The y values, I can just read right off of my graph. They're the things that I wrote in red. At pi over 2, it hit the minimum, which is at -1. Then it went to the middle at 1.5, then the maximum at 4, back down to the middle, and then back down to the minimum at -1. So there's a table of the 5 key points. We're being asked to draw 2 cycles, so if I just continue that pattern backwards or forwards, I'll have one more cycle. So notice when you look at my answer key, it doesn't really look like I graphed the phase shift, but I did. It just turns out that graphing one more cycle backwards ends up right on the y-axis, and that's just a coincidence.